Hi, today we're going to take a look at perpendicular bisectors of triangles. So perpendicular meaning we have two lines that cross each other and they form a 90-degree angle. A bisector means it cuts that segment, cuts that angle, cuts anything into two equal parts, and we're going to be looking at triangles. So up here, I've got perpendicular lines, we know because we have a right angle. I have points and then that going on. So I have 2 points here. This is a perpendicular bisector. It bisects this line, so those are the same distance apart. Now, what this rule says is when you have that perpendicular and that bisector, this line and that line, those segments are going to be congruent to each other. Okay, let's use that to find some information. So first one, I know I have a right angle here. These two sides are congruent, so we have a perpendicular and it bisects this whole thing. So this distance from A to D is going to be the same as A and B. So that's 6.3, that's 6.3. On the next one over here, I know that my distances are the same at both at 7, so that means these have to be the same. So if this is a distance of 3, this has to be a distance of 3. So I know YZ is 3. XZ is going to be this whole section. So you got 3 plus 3, giving us 6. And be careful, that Y labeled here, it's a little sloppy, but it's for that point right in the middle. Okay, last one. Now we're going to actually put some algebra to this. We have a perpendicular lines. This base here is split into two equal parts, so we bisect that. Once we know these are the same and we have that perpendicular, we know these lines are the same. They're congruent to each other. So in order to find everything, let's set these two equal to each other. So we can say 2y and 3 equals 4y minus 7. And let's start moving things left and right. Minus 4y, leaving us with negative 2y and 3, minus 3, negative 2y equals negative 10, divide, our y equals 5. So that's one thing we need to find. Now we need to go back and figure out what HE and FE is. I want to take that 5 and I want to plug it back in. So I'm going to say 2 times 5 plus 3 gives me 10 and 3, gives me 13. So HE is 13. Do I actually need to plug that in back into the other side? Not necessarily, because I know that if this is 13, that's got to be 13. You can plug it in the check, but they both end up with the same thing. And that's using perpendicular bisectors of triangles.